Awesome. So yeah, let's go ahead and get started. So I'm going to be going over Flux, which is our internal querying language, and our new feature for edge data replication. So I've already been introduced, but just to clarify, my name is Zoe Steinkamp. I'm a developer advocate here at InfluxData. In my past life, before I became a developer advocate, I was a front-end software engineer mainly in React. And my interests outside of technology include traveling, cycling, cooking, and gardening. I've also included a photo of my one and only pet snake, Snakey, and my LinkedIn QR code. So really quick to go over the session agenda. The first thing I'm going to go over briefly is the InfluxDB platform overview. This is just to get everybody on the same page. A Flux overview, which will just go over some of the features of Flux, some of the bigger features that we like to highlight, as well as a real-life example where we're going to kind of walk through a simple query just to get an idea of how it operates, how you write it. And then I'm going to go into the edge data replication overview. I'm going to show an edge data replication example and a demo if time allows. So going over the InfluxDB platform. So really quick, time series data. So just to clarify, time series data is any type of data that is time-stamped in some way, whether that be every hour, every minute, or every second. And the most important thing is that you want to query and analyze that data on time. You can think of things like IoT devices or your Fitbit or other server monitoring applications. When it comes to physical spaces, like I just mentioned, it's going to be devices and sensors. When it comes to software, it's going to be things like containers, applications, networks. It's got a pretty broad range when it comes to industries, from things like energy to financial. But the overview is that time series data is pretty much everywhere to an extent, but depending on what you want to do with it is whether or not InfluxDB actually works for your use case. This is a very nice little overview of the overall InfluxDB architecture. So we have our data sources. That's the stuff I pretty much just mentioned, just places where that kind of data comes from. Then we have Telegraph, which is our open source ingest agent. It's one of the largest open source ingest agents specifically for time series data. It's used not only by us, but by some of our competitors as well. It's that popular. And for the most part, all the plugins are supported either by the companies or the products that actually have those plugins. So we're more of the caretakers per se than the full owners. The client libraries, which are basically just packages that we've set up in all of these popular languages where you could just download it or run npm install and then just run basically. It takes less than 10 lines of code and you can just start writing up to Influx. And then a few native ecosystems. Basically, all of this brings the data into InfluxDB. And from there, you can obviously store it, but you can also start to do things like transformations, triggers and alerts, and downsampling. And that's all core Flux capabilities, to be exact. Finally, all of this powers things like application workflows, infrastructure insights, and in general, IoT actions. So that was the very brief overview of Influx. So now I'm going to go a little bit deeper into Flux with a first Flux overview. So InfluxDB comes embedded with the functional data scripting language called Flux. It allows you to build data pipelines to query, analyze, and transform your data. The perks of this is that the analytics happen server-side rather than in your application. It's also unified across the entire InfluxDB platform. So that basically means it's an all-in-one solution across the entire platform. You don't need to learn multiple tools or multiple languages to do all the things that you want to do. And obviously, you don't need to use third-party or client applications either. So to basically summarize some of these advantages, it queries for time series data, it helps you manage the life cycle of your data, it helps you alert on it, and it helps you in general clean it and analyze it. Now I'm going to start covering a little bit more of those capabilities in depth. So what can you do with Flux? So it comes with a number of packages and tools, and they're way too long to list all of them. I'm going to highlight a few of them. A big one is custom aggregation. Custom aggregation is when we want to, per se, find the data average for an hour, for example, or maybe we want to aggregate down, as we like to call it, downsampling. Maybe instead of your IoT sensor sending you data every second, you aggregate it down for your actual visualization and analyzing down to every minute. I'll go into this more in depth in a second. You can define custom functions yourself. An example of this, but essentially you can also pull your data and send it to a variety of data sources. That can be buckets, MQTT, or REST. Tools that those of you more familiar with SQL might recognize are things like joins, maps, and pivots. and a few more advanced features, including covariance and smoothing, which I'll go ahead and go into. So, Flux data processes and analytics. So it has these functions for broad use, but I am going to clarify that they're more specific for the data science sphere. But basically, we have some transformative functions for statistical time series analysis. Those are going to include things like correlation, standard deviation, quantile, and spread. We have the transformative functions for dynamic statistical and fundamental time series analysis. Those include moving averages, double moving averages, time-weighted averages, and like I said before, double and triple exponential smoothing. Finally, we include technical momentum indicators for financial analysis, including Kaufman's adaptive moving average and Shonday momentum oscillator. We also include math packages for math applications and geo packages for geotemporal data. And finally, the final one, which I'll go more in depth as we go through this talk, is the edge to cloud. These are more time-focused features, as I like to call them. This is a pretty long list here. But basically, I just want to highlight some of the functional capabilities when it comes to time. The duration to define query time lookback and calculations, that one's pretty straightforward. It's one of those things where it's like, I would like all my data in the past, hour, past 24 hours, et cetera. Time unit conversions between nanoseconds and an RFC 339 timestamp, which just to note is how InfluxDB actually expects the timestamps to be stored in the database. I'm going to leave this list up for a minute so you can just read it briefly. Going forward. So these are some features specific with our SQL package. So InfluxDB has a SQL package that comes with functionality specifically geared towards working with SQL table data. Some of the reasons you might want to use this are because you're joining relational data with time series data. Sometimes time series data can be a little bit, I guess the word is, it's a very specific data stream and it might not have everything that you need per se, so you might need your relational data to kind of combo in with your time series. It reduces cardinality, and we also offer support for most SQL DBs in this package. You can find out more information online, but we support most of the major ones. These are advanced Flux features for anomaly detection. I've actually been asked about this a lot at this conference. We have a few options when it comes to anomaly detection. We have a few like libraries or functions. The big three, I would say, are a third-party Flux package called Anais Anomaly Detection, our MAD function, which is a median absolute deviation, and we also have an algorithm to identify when time series is deviating from the pack. Again, you can find a lot of these examples on our blogs, on other people's blogs, on GitHub. I wasn't going to go super in-depth because, again, these are kind of more advanced. Finally, a downsampling task. So this is a pretty big one. The big thing with downsampling, you can either do it before the data goes into the DB or pretty much whenever technically, but it's normally commonly before or after. The before is because you want to clean up your data before it even hits the database. You want to go ahead and aggregate it down, maybe something, again, like I said before, instead of seconds, you want minutes or even possibly an hour. It obviously saves you money if you're not storing as much of that finite data if you don't require it. But maybe you do require it, it goes in, you do some real-time analytics, some real-time monitoring on it, but now you don't care about what happened, a day, a week, a month ago. You still want to keep a general idea of the data, but you don't need it so finite. That's when you downsample on the backside. And for historical storage, you go ahead and aggregate that down for a much smaller package. This is not a common tooling in a lot of databases, but it's a very specific problem to time series database or time series data in general. Again, over the long haul, this can save a ton of money, a ton of time, and a ton of resources. We have our checks and alerts. Under the hood, all checks and alerts become Flux query, which I'll go into in the next slide. But this GUI is just a little bit easier to explain it, and it's honestly a little bit more visually appealing. Basically, a check is pretty straightforward. We have a threshold or a dead man. The dead man is what it sounds like. It means the data is no longer coming in, and you are running a check to make sure that doesn't happen. You're still getting data from your ingest. The threshold is probably the more common one. That's when you can set a status, for example, to warning or critical or just to info. But basically, it's to be, hey, the data is going above or below, and I don't really like that. That's not what I want. You can pick an endpoint. In the UI, you can only do PagerDuty, REST, or Slack. Basically, that's where the alert would go. That's where you would send a warning that says, hey, the data has sent me a it's going up to a warning level that I don't like or a critical level that I don't like. Let me know. And then finally, just the rule, which basically says how often to send that message. As I said before, under the hood, this is what it looks like. This is the Flux code that you would get from, maybe not that exact version that I just put up, but basically the same. You can also go ahead from here and create your own custom checks and notifications. You can do, obviously, a lot more capabilities if you can write Flux custom. I personally normally just go through the UI GUI and then just go find the Flux code and edit it from there. Why take extra steps if I don't have to? You have a lot more variety of endpoints when you do it this way. I've put a few right here at the bottom. I'm actually going to go on to the next slide because this is some of the ways that a lot of our clients are using us. So obviously, the GUI is kind of limited in the endpoints, but overall, it's pretty much the world's your oyster. These are just some of the ones that people are currently doing. So now I'm going to go quickly through a brief Flux example. This one is, so basically what we're going to do here is we're going to calculate the mean fuel value across generator IDs. The idea with this question is that imagine you have a few generators that have fuel. These are, emergency generators. You just want a mean idea of how much fuel is in all of these. Obviously, in reality, you'd probably also be checking them individually, making sure nobody is suspiciously lower than the others, but for this, we're just going to be doing the mean. So with this, the first thing that we're doing is just querying our data. Our bucket is just that. It's like a bucket storing water. This is where your data is stored. You can have many buckets. You can also call from different buckets if you wanted to use, multiple data streams. But for this one, we're just querying from one bucket. We're going to make it simple. From there, you basically give it a time range, and you filter down. So what we filter down is into generator data. We want the fuel, and we want 3 generators, the ones with the IDs of 1, 2, and 3. Very simplistic. For this example, and just in general, we've dropped the 2 columns start and stop. They're just not necessary, and it will make our table in the next slide just a little bit easier to read. We've also gone ahead and limited down to 2. So we're only going to get 2 values for the fuel for generator ID 1, 2, and 3. And basically what that's doing is it's just averaging those and dropping them into 2 columns. As I said before, this is the table resulting from that query. It's a little bit easier to understand once you actually see the table. It's worth mentioning here that the default columns are actually being grouped. You can see these from the column titles highlighted in pink. Depending on which columns are grouped affect how the rows are actually grouped together. As you can see, we have 3 tables here. We have tables 0, 1, and 2. And they have the generator IDs of 1, 2, and 3. And each of those have 2 values currently. Next, what we're going to do is change the grouping of our data by using the group function. This is useful when we want to perform aggregations and other calculations based on specific subsets of the data. For example, we want to calculate the mean. So in this case, we want to group all of the generator data into one table. So to break it down, we're using the group function to group by the measurement, field, and host. You can either use the by or the except. This determines whether the stated columns are going to be included within the group or excluded. In green is the equivalent to just using the except parameter. Obviously for us, we had a shorter list for the by, so that's the one we picked, but obviously you can see in the future, if you want to do everything but one except, that would be the faster query to run. As you can see, now the only ones grouped are going to be measurement, field, and host, and now everyone's in one table called 0. So everyone's in the same table, so this is going to be a lot easier to run the next function on, which is the aptly named function of mean. So this falls under a Flux category called aggregators, and there's 2 families which exist here, aggregators and selectors. So when it comes to aggregators, they produce a single record, just one row. We'll have the same group key as the input table, which in our case is going to be 0. And the table generated will have the following columns. The aggregated column, which defaults to value unless you specify otherwise, and the columns that were contained in the group, which for us is going to be measurement, field, and host because we already defined them. All other columns are going to be dropped. Examples of other aggregators can include the mean and the mode, and a few other on the list. Alternatively, our other family is called selectors. We're not going to be using them here, but they do have the following features, which is a little similar, is that they contain 1 or more unmodified records. Equivalently, it will have the same group key like aggregators do. And examples of selectors are things like first, last, and distinct. Basically, this is when you want to ask for the last record in the table or the first record in the table. This is what you would go ahead and run. And this is that end result from that query. You can notice that the time column was removed after running the mean, as it was not included in our group key. In fact, now all columns that were not part of that group key outside of values are now removed when using the aggregator like the mean function. This is another way of running that, that whole query basically, but a little bit more simplistic. And this is something that DevRels see a lot in our community, and we just kind of like to highlight it. But essentially, if we run group with no parameters, this will remove all the columns from the groupings, but you'll still receive the mean value. So that's going to pretty much wrap up most of the overall Flux training. If you want to take a deeper dive at Flux and get more into this, I'm going to have more resources at the end of the talk. But I just wanted to highlight InfluxDB University, which has a completely free course on Flux, and it's a great overall resource. And some of these slides were actually from InfluxDBU training. So now I'm going to get into edge data replication. So version 2.2 of InfluxDB is introducing a new feature to automate the replication of time series data to other InfluxDB instances. We're going to have a durable disk-back queue with buffering to withstand planned and unplanned disruptions in network connectivity. In addition, this feature configures replication at the bucket level, so developers and operators can precisely define which sets of data to replicate and where to send them. This replication happens on write when time series data arrives at the edge and matches a replication rule. The open source immediately mirrors the data to the remote bucket defined in the configuration. And when it cannot send the data due to connectivity issues, all events are going to buffer in the local queue until connectivity is restored. The size and retention of the durable queue are completely configurable. So I'm going to go a little bit more now in depth into all this. But first, I do want to mention some industry verticals and use cases. Now, obviously, we all immediately jump to the thought of some device in the middle of nowhere with relatively low internet connectivity as the obvious use here. But that's not quite always the case. Sometimes even in things like retail, where you have stores and stuff like that, or even in manufacturing, which kind of falls sometimes in the middle of nowhere category. And even banking, where you're dealing with people on mobile apps. There's lots of connectivity disruptions. Even during this conference, I was doing a live demo of this, and my laptop occasionally goes to sleep, or occasionally the Wi-Fi in events like these cannot be that great in general. So occasionally connectivity goes down, but then eventually when it's reconnected, when I go back to my hotel room later, all the data just goes ahead and goes on up, or when I put it back out of sleep. This is just, a simple example of that. So I'm going to mention the to function. So this is how people were doing this for a very, very long time until we finally, came up with the full edged data replication feature. I do want to mention this. The to function, by the way, is not a bad function. It's just being used in a way that it was probably just not originally intended for. Normally, it's used for downsampling historical data. It's just something where you're like, I want to aggregate and then put it in that bucket over there. But basically, what people were doing is they were using this to function in open source cloud running on, open source Influx running on their edge device or their computer, and then they were pushing that data up to cloud. This had a few different problems with it. The limitations were, 1, it's unsecure because it's being sent over HTTP, not good. 2, there's no built-in functionality for failure handling, so it doesn't even work that well for the intended purpose per se, because with some connectivity issues, eventually data is going to be lost, unfortunately. And there's no built-in functionality for batching or retries or parallelization. Basically, it kind of worked for what it was doing, and it did actually work okay for pretty small data samples and people who kind of built in their own failure their own failure handling, but overall it was just not a great solution, which is why we built one that actually did meet the needs of our community and customers. Tangibly, this feature consists of 2 new API endpoints, remotes and replications, and 2 new CLI commands, also called remote and replication. But this is just a little diagram of how this is going to work. Basically, you run on your edge device an InfluxDB OSS database. Again, for this conference, my computer was that edge device. You are running Telegraph, or you can run the client libraries. You're running something basically to get data into the OSS instance. From there, it's got that bucket with the queue, like I had already mentioned, and then you're running some Flux code. Maybe you're downsampling, like I was, just directly on the edge device, or you're just running task on it, etc. Finally, when those commands are run, or rather when you are reconnected to the internet and these commands are running in the background, it sends it on up to cloud. So obviously, this is great for, this enables raw data replication, it enables downsampling, and consistency overall. So let me go ahead and go over those two commands. So obviously, with these two commands, we're keeping in mind that you're using an open source instance on your edge device and you're sending it up to cloud. It just makes it a little bit easier to talk about. But basically, with this remote create command, you create a remote connection to replicate your data. You just need to provide the following when you do it. You need to provide a remote connection name, which is a name of your choosing, a remote InfluxDB instance URL, your InfluxDB API token, which does need to have write access to your target bucket, otherwise it will not be able to write to it, and a remote InfluxDB organization ID. So this is all pretty straightforward stuff. If you're using client libraries, if you're using Telegraph, you pretty much already have to feed it a lot of this information. Finally, we do the Influx replication create. This is going to create the actual replication stream. With that, we're going to provide the following. Again, a stream name of your choice, a remote connection ID, which you would have gotten from the last command we just ran, a local bucket ID to replicate the writes from, that's the one on your OSS instance, and a remote bucket ID to replicate the writes to, that's the one on your cloud account. Once the replication stream is created, it will replicate all writes to the specified bucket to the remote InfluxDB bucket. And you can also run the Influx replication list command to view information such as your current queue size, max queue size, and latest status code in general. Some important things to note with this is only write operations are replicated. Other operations like deletes or restores are not going to be replicated. In InfluxDB OSS, large write request bodies are written entirely. When replicated, the write requests are sent to the remote bucket in batches, the maximum batch size being currently 500 kilobytes. And so this may result in scenarios where some batches succeed and others fail. One thing that I was doing on my edge device, and in general I find a lot of people seem to do, is you might not want to write your raw high precision data to your cloud instance. You only want to replicate your downsample or pre-processed data. So again, this is also really common in general with IoT devices. They just send a lot of data. Some of it's useful, some of it's kind of weird and gibberishy, and it's just not super great sometimes. And in general, we don't always have a ton of control over the data we're getting. We get it, but then we have to deal with stuff. That's why, dropping tables is kind of common, or just dropping columns. So with this, you can obviously run a downsample tasking aggregate, or you could just run in general a task, and you could just clean it up, get it smaller, get it to about get it to what you want it to look like. And you can do that all on the edge, saving you processing power and time. And then you just go ahead and send that on up the line to the cloud, which is exactly what these lines of code are doing here. So this is an architecture diagram for our Plant Buddy demo. So this was actually the project that we had at our booth this week. But basically, this is an overall architecture diagram for it. The idea being that we were monitoring the health of a household plant. And specifically, we wanted to monitor that data on the edge in an OSS cluster, clean it up and downsample it. And then we go ahead and send it up to our cloud account. In the cloud account, we add some alerts and notifications as well as visuals to go with our project. So to go a little bit more in depth on this, basically the plant had about 4 different IoT sensors on it. And those IoT sensors were being used with a microcontroller to send the data into my OSS instance. In the OSS instance, I was cleaning it up not only because the IoT sensors were sending, like I said before, somewhat relative gibberish. The numbers they send in don't even look human readable. So we go ahead and clean that data up. Then we're using a Telegraph ingestion agent to get that data into OSS. I think we're using a MQTT endpoint, but regardless, basically we're getting it into the bucket. And then we downsampled it a little bit more even. We went ahead and said, I don't need the plant data for every second. I just don't need it that intricate. I want it down to every minute, so it's not as large of storage on my cloud account, even though I have a magical free one. So I could store as much as I want. But regardless, we went ahead and downsampled it. And from there, whenever connectivity was working, whenever the internet was doing great, it would go ahead and send it on up to the cloud. From there, we had a few visualizations, which I'll demo and show in a second. And we actually had an alerts and notifications set up that basically said that if the moisture sensor in the soil got below about 14% to send me a text message and let me know to water it, of which I promptly ignored. I don't think that plant got water all week. So obviously, these are some links for trying it yourself. As I probably have I don't know if I actually said it out loud, but we are fully open source. We're on GitHub. We have open source, and then we have our cloud platform, where it's a pay-as-you-go model, but it's free for everyone to start. That's what these two links are. The left one is the cloud. The right one is our GitHub. We have an extremely active community. I already mentioned InfluxDB University, but we also have our own forums and our own Slack channel, where I can assure you it is super noisy because I get notifications and people are on there all day and night, just answering and asking questions and talking in general about the platform and use cases. These are also just an overview of further resources. So we have our Getting Started, which is just the cloud pretty much, our forums, which I just mentioned, in Slack. We also have our book, which is called awesome.influxdata.com. It just kind of goes over some of the core features. It's not necessarily documentation as much as it's more theoretical as to what we do. Our actual docs, which are what you would expect to be, documentation, more serious, as I could say. Our blogs, which have a ton of resources and a ton of use cases, and honestly, they just have a lot more than you would think a normal blog would have. And of course, InfluxDB University. So I'm going to go ahead and see if I can mirror my display here so I can run a quick demo. Okay, let's see. Cool. Yeah, there we go. Cool, so I already logged into my account, so I could just show this really quick. So this is our cloud platform. This is a little bit easier, and I don't have to run anything on my computer to get this going. This is pretty much exactly what it would look like, though, if you were to download and run locally our open source. Oh, give it a second, I just gotta refresh the page. When it reconnects to internet, it gets a little weird. So basically, this is my plant buddy bucket. It's not going to have more recent data just because the plant hasn't been plugged in today yet. But if I go back by about 24 hours, you can see this is yesterday when I was at the booth. This is the plant actually sending in data and graphing it. So this is pretty cool. Obviously, it'd be cooler if it was a live stream. One thing I did want to highlight, which I think a lot of people find pretty cool, if you want to get started in Influx and you're not sure about how it's going to work for data, we do actually have this sample data right here in our notebooks. And let's give the internet a second. I'm going to show off kind of a cool graphing visualization that we have. We come out of the box with a pretty standard set of graphs, as well as a few more advanced ones. Specifically, I'm going to go ahead and show off our map one, which we're pretty excited about overall. Let me go ahead and run this. And let's go down here. So yeah, this is the full list of our graphing. I'm not gonna, it's pretty easy to find, so I'm not gonna go super in depth on it. But this is normally where I tell people to go basically check us out and see how everything operates. So this is earthquake data. As you can see, this is the earthquakes that we've had in the relative California region in the past hour. If I go ahead and put in the past 24 hours, we're going to see a lot more dots. Yeah, there's lots of earthquakes right here. And yeah, you can quite clearly see, if you go up here to Alaska as well, you can quite clearly see where they're very active. But this is a really cool thing to just get started on. I would say when it comes to these sample data sets, the air sensor data is a lot more similar to IoT type use cases. That's kind of like my plant buddy one. This one reminds me a lot of our customers who use us for things like tracking animals or tracking shipping containers, a less fun one. I prefer the animals personally. We also do have dashboards. I always like to imagine notebooks are more, like asking a different question every day or working with coworkers. They're more for on-the-fly decisions. You can imagine a dashboard just like you would imagine a dashboard for server monitoring. It's more static. You build them yourself, though we do have a few out-of-the-box templates already. Oh no, I did not mean to pull that. This is just a dashboard for my plant buddy. This is just pretty simplistic. Me and my coworker built it out. Again, obviously this is old data that it's drawing from, but because I've got it set for the past 24 hours, I still have most of my dashboards running. And as I mentioned before, these are just tasks. These tasks that look a little bit weird were created out of a notebook, but most tasks are pretty, let's see if this one opens up. Let's see. Yeah, so as I said before, tasks are either alerts and notifications or they're downsampling normally, but basically everything kind of ends up in this space on the UI. And this task is just checking the moisture level for our plants. And these are just a few of those checks overall. I'm not going to go super in depth into some of these. It's just a lot to go over, basically. And like I said, when it comes to templates, I do suggest checking out our community templates. Some of them are more serious, as I would say. They're things like AWS CloudWatch monitoring. Some of them are a lot less serious. They're things like, let's see, where is it? We have a lot of gaming ones on here. People really like to track their game stuff. Oh, there it is, like Apex Legends player metrics. But basically, that is my just quick overview. Also, if you did want to see all of our Telegraph inputs, you can go to GitHub, but you can also search them here. Not all of the plugins are in the UI. I'd say maybe like 250 are though, so the vast majority. And you can always create one if you technically needed to. And really quick, just to highlight, when it comes to the client libraries, like I said, for this, it's just a quick pip install package. These lines of code just initialize everything. Again, it's where you tell it like the org, the bucket, the token, just the normal stuff to get the data up. And then this is all the lines that you need to actually start writing. It's extremely simple. It's not super difficult to get started. And you can run a similar Flux query to get that data all back out of your bucket. Say you want to display it in your own graph, or you have an app or something where you need the data to go to, not a big deal. But yeah, that's going to be my overall. I'm going to go back to the resources just because in case anyone needs them. And if there's any questions.
All right, I think we have time for maybe one or two questions. So does anybody have any questions? Okay, wonderful. You really downplayed it. You're super humble. Like Zoe said, it's completely open source. So if anybody is interested in becoming a developer or a contributor, I'm sure Zoe could help you there. There are a ton of community resources as well. Like Zoe said, there's the Slack channel, InfluxData forum, as well as Reddit. Go take a look at them, download InfluxDB, and go give it a spin. And if you have any other questions, feel free to reach out to Zoe. If you're joining us online, please remember to rate and review this session. Thank you so much for joining our session. Cheers.